it starts over. Okay, so again, the first thing I have in my notes is electromagnetic waves. And electromagnetic waves can travel through empty space, unlike what other kinds of waves? Sound. In fact, we know that electromagnetic waves can travel through empty space because would we be able to see the light or feel the heat or get sunburnt if those electromagnetic waves could not travel to the earth? Okay, no. So, of course, they can travel through empty space because they get from the sun to the earth, right? All right. So, the characteristics of a wave. Amplitude is the distance the wave oscillates from the rest position. This is the distance the wave is traveling from the rest position, okay? How far it goes up, how far it goes down. Wavelength is the distance from any point on one wave to the same point on an adjacent wave. Example, crest to crest. And that word adjacent, that's like next to. The person that lives adjacent to you is your neighbor. Okay? That's what that word means. Frequency, the number of oscillations produced in a certain amount of time. I put in parentheses VPS, vibrations per second. Waves per second, that's frequency. Waves that have a higher frequency have more energy, and frequency is measured in hertz. 1 hertz equals 1 wave per second. All right, wave speed. The distance a wave travels in a given amount of time is wave speed. All right. Waves move faster through some mediums than through others. We learned with sound that sound travels faster through solids than liquids or gases, right? Well, for light and other forms of radiation, solid materials can block them, can make them slow down. For example, when the sun's light hits water, does the light go through the water? Yes, but it slows it down. Okay? Some radioactive particles have enough energy to penetrate people. What's an example? X-rays. Okay? So these types of waves can also go through solid material, but solid material slows these particles down. Okay? And then down here at the bottom, I have a picture from the notes. And this picture just shows the examples of different wavelengths. And it also shows amplitude, rest position. Okay? So next in the notes, I have different kinds of waves. There's transverse waves. These are the waves that go like this, up and down. All right? And then look, where we have the waves are perpendicular, the direction of the wave is this way, but the matter goes up and down, so it's perpendicular. Examples include light waves and S waves. Those are the secondary waves from an earthquake. All right, here's another picture of a transverse wave. This is like our prime time. I have the amplitudes, I have the crest, the trough, and then the perpendicular, the right angle over here to show that it's perpendicular. Okay. All right, for review, we still had to put down information about longitudinal waves. And so we have our compressions where the springs are closer together or the particles are closer together. The rarefactions where they're spread out. Compression, rarefaction, and examples would be sound waves and primary waves, P waves. All right, so now we're going to talk about light because light travels through transverse waves. And light is the vibration of electrically charged particles. I added in my notes darkness. Darkness is the absence of light. I can only see you guys right now because there's light reflecting off of you. If all the light was traveling through you, you would be see-through. And if there was no light, it would be dark. Okay, who's ever been somewhere where it was so dark you couldn't even see your hand in front of your face? Okay, that can be pretty scary, especially when you wake up and you forget where you are. You can't even see your hand in front of your face. That's because there's no light reflecting off of anything that comes back to your eyes. Okay? So you can only see objects that light reflects off of, or objects that produce light themselves. What are some examples of objects that produce light? A lamp, a light bulb, the sun, lightning bugs. What? Flashlights. Okay. Now, I have a question. Is the moon a light source? Does the moon produce its own light? Okay. So listen. I think it's natural and I think it's common to believe that when you go outside at night and the ground's all lit up and the moon's all big and it's bright, I think it's natural to think that the moon is producing light. But where's that light coming from? It's the sun's light reflecting off of the moon. Okay? So the moon is not a light source. I know it might appear as one sometimes, but it's not. Okay, so the next thing we have is the electromagnetic spectrum.